So we're going to talk about the string matching problem. So string matching problem is given two strings S and T, and S is a long string that have length n characters, and T is a pattern that you're trying to look for. Okay, so what happen is, for example, if you have a long string, so you have a haystack here, that's your S, and you're looking for some occurrence of, let's say, ST. Okay, so in this case, M is 8 and N is 2. So you can, of course, just use S dot find T in STL, and that will return, of course, the first occurrence. How does this function actually work? It's going to start trying to match the first letter of T with the first letter of S. Doesn't work. Then it's going to try to match the first letter of T with the second letter, and so on. And eventually it will shift it to this one, and it matched. And then it will try to match the second letter with the next one. It matched, and everything is good. Right? But sometimes STL find is actually rather slow. How can that be? Imagine you have some very problematic string like this, and you're trying to search for this. What happens is, at the first position, you're going to spend 3 steps to find out, or 4 steps actually, to find out that nothing matched because the last letter doesn't match. So what are you going to do? You're going to then shift it to the next one and try again. Of course, 4 steps later, you realize it doesn't match, and you try again in the next position, and so on. And if you do it this way, the running time is actually m times n, quadratic in the worst case. And if you use the STL version of string.find, this is exactly what happens. It's it's quadratic in the worst case. So there's another way that is, there are actually a number of different string matching algorithms that are much better. And the one that we want to look at, it's KMP, stands for the 3 authors of this algorithm, Knuth, Morris, and Platt. And what it does is it first figures out, it looks at the pattern that you're trying to search, and it does some pre-processing. Okay, some pre-processing. And it builds some table, let's just call it a table, in linear time. Okay, linear in the length of the string, of the pattern. Okay, so every time you want to search for T in any S, you can just use this table. And then this algorithm, the KMP search algorithm, would read S with your table for T that you have already built. And in linear time, back over the length of S, it will be able to find every single occurrence of the string. Okay? And so, of course, you need to do the pre-processing, and then you can scan, but it's at the end, it's the complexity is the sum of the 2 lengths instead of the product. If you're searching for the same pattern in multiple strings, you only have to do the pre-processing once, right? But even if you're only searching for T once, for one single S, it is still faster than S.find in the worst case. Because S.find, it's quadratic in the worst case. And this, I would say, for those of you that have taken Computer Science 3630, this table is essentially like a finite automata that somehow allows you to scan this string looking for the pattern AAAB. It's almost like a finite automaton for this substring, right? And the code in the code library is KMP .cc in lowercase, actually, not uppercase KMP.